the Maztec. Fluke 101, the Unity, the BK Precision, the Centec. This is the X-Tech. Here's the AMPROBE. This would have been from Harbor Freight. Gardner Bender, the Klein. I don't know if you heard that, but it just blew something off. It hit the other side of the room. Wow. Oh yeah, look at all this. When I flipped it upside down. Yeah, it's all the crap that just came out of this meter here. Looking at. Whew. Huh. Shit. Holy crap. Wow. Something else just flew off. During making these videos, I talked about using IEC 6110. A lot of people are confused by this, thinking that the meters don't need to survive. My goal was never to see if the meters actually would meet an IEC standard. My goal was to take a bunch of low-cost meters and put them against each other in some type of an electrical test and see which ones were more robust than others. And because there are no standards really for doing this, I chose the 6110 because it actually talks about multimeters and their uses. As I started out at a very low voltage, in this case 2000 volts at 50 ohm source impedance, and much shorter pulses, so 10 microseconds, so half the width. If meters were all tested to that standard, ones that pass that, I was saying, okay, those are more robust than the other meters that don't. Again, it's not about trying to determine if these meters meet what their requirements are. I'm not an accredited lab. You know, if you want to know that kind of information, you're going to have to take these out and have them certified. I'm not trying to certify them against an IEC standard. I'm trying to determine which meters are more robust than others. And I want to do something more than just drop them off the roof of the house and drag them behind a car to make that claim. I want to actually do something with them electrically. So that's been the goal of this experiment all along. Try to find the meter out of the 12 or so that I tested to determine which one was the most robust. I mean, those of you that feel that these tests are not appropriate for evaluating meters' robustness, you're free to go off and come up with your own set of tests and run them. I would say that's true for the manufacturers. I think it would be helpful for people to see more testing of these meters and something that's more appropriate in how they're going to use them. So anyway, the meters did sort out pretty good. We got down to these last two, so you know, right or wrong, I would say these two, at least by my investigation, are better than the other ones I've tested. If you have been watching the videos, one of the things that you might have noticed is that many of the meters will arc uncontrollably on the inside of them. I've seen things like resistors arc over, PTCs arc over. There was a meter that one of the PTCs lost the entire casing off of it. If you consider the IEC 6110 surge testing and you look at an arc like this and there's no fusing in there to extinguish the arc, I mean, I would have a lot of concerns whether a meter that arcs like that would even pass the IEC standards. So again, don't consider any of these tests that I've performed any kind of indication whether a meter would pass that test or not. You know, I just don't know. But I don't like the fact that a lot of the meters do arc internally at tests that are well below what the IEC standard calls for a Cat 600 volt meter. I'll take it for what it's worth. And the last thing I want to mention again is that this testing isn't something that any of these manufacturers had contacted me about performing. I'm not affiliated with any of the manufacturers. A couple of friends of mine have brought in some meters from home. Other than that, I purchased these meters out of my own pocket. I ran these tests on my own with my own equipment. It was out of my own curiosity, and I just thought I'd share that with people that are interested in the subject as well. There's only 2 meters left. We're down to the finals. We have the AMPROBE AM-510. Very nice meter, a lot of features. It's held up very nicely during the test. Next to it we have the Fluke 101. Also a very nice meter, not as many features. I don't really care for the continuity tester on it, it doesn't work all that well, but it's held up again very well. These meters have beat out every other meter I've tested. The Fluke is quite a bit smaller than the AMPROBE, but again, the AMPROBE has definitely a lot more features. You know, really at this point here, either one of these I would say is a pretty good meter. They're both under 50 bucks. Before we do that test, let's take a look here at this box of failures. I'm thinking, you know, we really need to do something with a few of these. Someone had asked about doing a video on repairs. I think I can squeeze that in here, and I got some of my own ideas maybe on how to dispose of a few of these meters, so we'll do that as well. The Klein does not appear to be stronger than a set of channel locks. I'm not sure where the arcing came from. It appears that the source may be dead, and that's why it doesn't work in ohms mode. Let's see if we can tell where the breakdown is. If you can see this, but the PTC is actually what's breaking down. Let's see how the meters do against a 12,000 volt neon sign transformer. Meters should survive this. Here's the unbranded meter. Looks like a hazardous condition to me. Yeah, somebody could get hurt with this meter. Here we have the Unity UT139. Didn't do real well in our test. Yeah, let's see how she holds up in this round of testing. I don't know. Didn't survive the drop test. Looks like we broke the LCD. Yeah, I don't know. Oh well. In case you're wondering, Easton. Somebody had asked about putting together a video on how to repair some of these meters, see if it was possible. So we'll try this one here. This is a Gardner Bender. This is the model GDT 311. I had done a preliminary failure analysis on it and believed that R18 was defective. First thing you're going to need is some tools. In this case here, we're going to need some jeweler's screwdrivers. I received these when I was a teenager from my sister, so I've had these for quite a few years. To start, we just remove the back cover. Now, my advice is use the cover as a container to hold your parts. Then you don't lose them. Now, there's the heart of the instrument. You can see the circuit board. That's the main IC. Up here is the resistor I believe needs to be replaced. Now, to do this kind of work, you always want to have proper equipment. Okay. To remove the resistor, I'd seen Dave do this in a video. It seemed to make sense to me. So, yeah, that's pretty good. Yeah, I think that'll work out just fine. I just replaced that. You know, the chip doesn't look quite right either. Yeah, I think that's an improvement. I think we just fixed that other bug this thing had. This is the Centec digital meter. The old B&K meter. This is the Unity UT90A. I had previously blown this meter up twice, and when I took it apart to see what all had gone wrong with it, there was a high voltage diode that was part of a clamp circuit that had failed shorted, and there were 3 traces that were in line with that had basically vaporized. These traces actually are on the selector switch, and they interconnect the different pads that make up the switch. The traces didn't like just burn a slot. I mean, the whole thing basically vaporized. There was no trace left at all. So as I started looking through, there were also 2 resistors that were down inside that had failed open. Using a microscope, I was able to rebuild the traces. I replaced the diode and the 2 resistors that had opened, and lo and behold, the meter fired up and ran fine. So I went through a alignment on it, and it probably works better now than what it did when I first got it. The continuity test obviously had failed before. You can see that's now working again in ohms mode. So you can see here, this is a 50 ohm load here. This is a 100 ohm load. This meter doesn't have auto ranging, unfortunately. But here's a 1K ohm. The voltage modes all work, so no problems with it at all. Yeah, I don't have any plans for the meter. Maybe I'll give it away or something later on, but what I wanted to show you now that that meter's running is this little device here. This was our attenuator, and for the testing we're going to run, the generator is now set at 6,000 volts essentially. This box is now going to protect this meter against this. This meter would never withstand this kind of voltage. So let's just go ahead, we'll put her in diode mode. You can see the meter doesn't even flinch. We could have the probes connected to any of these inputs now. As long as we've got this attenuator in line, that should protect this meter with no problems at all. It's actually designed for upwards of 12 to 14,000 volts. The probe leads here would definitely fail long before this box does. You can see it in ohms mode. Let me just go ahead and add a bias voltage to it. So that bias voltage is now just coming through the generator, just like normally. You can see I can vary it. And you can see those transients. It doesn't come through this box at all. So again, if you were wanting to protect your meter, this is a pretty decent way to do it. Because it is a balanced attenuator, it limits the current to the meter in both paths. And again, it can be inverted either direction, it really doesn't matter. You can see it's about the size of the meter. Yeah, I trust holding this thing even at that kind of voltage. There's probably at least a ½ inch of clearance between any part in the plastic box here, and all that is insulated with potting. Plus there's Teflon all over inside of this thing to prevent any kind of internal breakdown. What we can do is add a AC bias voltage. You can see it running in AC mode now. But yeah, no problem. It uses 4 sand-filled fuses. It's got all KDAC devices in it. I thought it was a pretty good demonstration of how well this kind of device would work. I've just finished increasing the output of the transient generator. And again, I'm using my Tektronix P6013 to monitor the output of the generator. Again, this is into an open. This would normally be a 1.250 microsecond pulse. Looking at the 64XI, see we're at 5 microseconds per division and 2000 volts vertical. We have a peak amplitude of about 5.8 kilovolts. That's what the wave shape looks like. You can see roughly it's about 35, 40 maybe microsecond decay. We're going to start with the AMPROBE AM-510. It appears we've damaged the front end for the resistance measurements. Okay, let's have a look at it. Okay, I've gone ahead and I've functional tested the AM-510. It appears at least the voltage modes still function. The ohms, the capacitance, the diode, continuity check, those all fail now. Frequency, duty cycle, that all still seems to work. So the meter has been damaged. We'll go ahead and hook up the Fluke and we'll see if it'll pass. We don't quite have a winner yet. It's really going to come down to if this Fluke 101 will pass these tests. If it does, this will be your winner. Tell you, if I had to pick a meter between the two of these regardless, it'd actually be this one. It's got a lot more features. I like the continuity test on this, actually works. This one here on the Fluke is not good. You know, I've showed that a few times now. But let's just go ahead and see here if the Fluke will pass these tests. As you can see here, scope's still being used to monitor it, and nothing really out of the ordinary. Still putting out a roughly 5.9 kilovolt signal. Nothing's changed in our test setup at all. Okay, here we go. Here's You can see the wave shape is very repeatable. Came down to the two Danaher subsidiaries, Fluke and AMPROBE, and the final stages of testing this Fluke 101. If it passes everything, this is our declared winner. So I'll say Fluke's come a long way from the first meter I bought. I'd have to they've definitely stepped up their game. Again, I'm not biased one way or the other towards Fluke or any of the other companies. This isn't something Fluke paid me to put together. I just did this on my own, out of my own curiosity. Everything was paid for by myself. There were no outside influences making any of these videos. Transient generators held up fine during all these tests. For being a homemade thing, I'm pretty happy with the results from this. It's been a pain to reconfigure it for all the tests, but I think the results speak for themselves. It did a good job. generator that would normally run these tests. And you're talking tens of thousands of dollars normally, so to do it for what I have invested in this little box, it just goes to show you don't have to spend a lot of money to get your job done usually. Not always the case, but certainly that seems to be true in this case. This isn't something I'd recommend you doing as a home project, I'll tell you that, unless you're familiar with working with high voltage. This box will definitely put out enough energy right now that'll could kill a human being, no problem. So construction practices are important. Handling. You can see here I've always had my ring on and my watch. But I will run this usually with the cover on. You can see it's fairly well protected here. It's that comfort thing that gets you killed. So that's the end of her. Let me just functional test this thing and we'll see where we're at. Okay, the voltages on it look good. Here we are on resistance. This is a 50 ohm, 100 ohm, 1K, 10K, 100K, 1 meg, 10 meg, still has a real poor continuity test. Never been impressed with that. Diode check looks okay. This will be 100 nanofarads. Looks good. Yep. Oh, there you have it. The Fluke 101, the clear winner of this competition. I'm pretty impressed. Compared to my original Fluke, yeah, hands down better. Great improvements. I think with my next meter I'm going to buy a real Fluke, spend some money, get a decent one. Probably be the last handheld meter I buy. There you go, your clear winner. You people shopping for meters, you can see I've gone through an awful lot of them here. I'm not going to say you get what you paid for. All these meters cost roughly the same amount. They were all under $50. There's definitely some that outperformed others. If you're looking for a robust meter, I think that Fluke 101, it's going to be hard to beat. The other Danaher one here, this AMPROBE again, very nice meter, held up very nice. Has some more functions than the Fluke. The continuity check works. It has this non-contact detector. I haven't actually tried any of these features out. I was just really interested in transient testing them, but you know, I'll leave that to the guys that do the meter reviews to check that stuff out. But there you go.